known in the name of discriminant. Okay, let's check first. Okay, live. What is live? YouTube. Okay, let's see first if I am live or not. Normally thought yes, I'm still live. Okay, yes. Okay. So learners, today, as we told that we are going to not to talk about polynomial to the power 4, but we are going to power 4, okay, by extending okay its power. So learners, to stop, okay, please, thank you, okay, thank you, okay. So now learners will just okay, I will just put my coffee first, okay, on the desk, then we are going to start, okay. So learners, we told that here it's an opportunity for you to learn new methods, okay, for solving polynomial to the power n, okay, whatsoever the highest power of let's say the polynomial you can start working on using by using the discriminant formula. Sultan Ezouidi. Therefore, learners, please, Papa, no, please. Okay, take my phone. Okay, take my phone. Okay, you can take it. Okay, but I need it, in fact, but no problem. Okay, so we start, learners. We told that today we are going to focus on polynomial to the power 4. Okay, yes, we will start. So we are going to learn a new method. Okay, the method is called discriminant formula of Mourad Sultan Ezouidi HSM. Okay, yesterday we already solved an example for you. Okay, today we are continuing solving polynomial to the power 4. Okay, but the secret here is to extend also the highest power of this polynomial to the power 4. Okay, let's move to question number 4. This is, we did it before. Okay, I'll just see the next example. Okay, and just wait for me. This is, we did it yesterday. Now we are going to focus on new example. Okay, and I want you to concentrate. The more you concentrate, the less you make mistakes. Okay, just okay, I'm going to see it first. Okay, example number 5 or 4, I think. Okay. Okay, this is, we did it yesterday. We applied or we practiced the discriminant formula of Mourad Sultan Ezouidi. This is 5H. Okay. So here, learners, we have an example. Okay. The example is that. Okay. The example is that polynomial to the power 4. Okay. P of x equal x raised to the power 4 minus 60x third plus 1440x squared minus 17,280 plus okay 103,680. Here, learners, the target of our example or the purpose is that finding out all the roots. Okay, we are going to find the exact value, okay, without using the, let's say, approximation method. Okay, so just check. Okay, so learners, here, as we told before, this is, in fact, is a polynomial to the power 4. Okay, simply because the highest power here is 4. Okay, so let's find first the polynomial, the roots of this polynomial. We should determine the value of SR of O the cube. Okay, this O the cube can be varied. Okay, means can be changed to 1, 2, 3, and 4. And when the K is different to 1, means that you are going to work with the powers of 0 of polynomial to the power n. Okay, so this formula is the most generalized formula. Okay, that has been discovered by me. Okay, It's called, in fact, discriminant formula of Mourad Sultan Ezouidi HSM. Okay, I'll just put this here. Okay, I'll just make copy for this. I need it. Okay. Now, learners, we told this is, in fact, is the discriminant formula of Mourad Sultan Ezouidi. So let's start working now. I will just suppose that k, or I will put k equals 0, okay, to find the value of s minus 1, okay. S minus 1 of all the r learners is 1, okay, by convention. Barhum, please, I have a listen, okay? Okay, take it to your mom. Take it to your mom, please. No, with your mom. My wallet with your mom. Go to your mom. Sonia, please, Barhum will come to you and give him my wallet, okay? خلاص I'm walking, Papa. Oh, no, مذيعوش. يلا, go. Okay, so my son Barham is looking for my wallet so that to put the money there inside. Okay, so we told that I will put k equal 0 to find the value of s minus 1, which is 1. Now, learners, I will proceed, continuing, let's say, the work. We have for k equal 1, we will try to find the s0 of r. Okay, meaning that, learners, I will just use the discriminant formula of Mourad Sultan Ezouidi when k equal 1. Okay, I will just write it here if it is possible. Okay, or here it's better. Okay, this one I will put it here, learners. So this one is that I will just substitute k, or replace k with 1. Okay, look what we will do exactly. This is k with 1. It will be 1 minus 1 gives you s0 of order r. Okay, the sum from 0 to k is equal to 1. Okay, also here combination n minus r, choose 1 minus r, n raised to the power r between parentheses negative L0 for the q raised to the power 1 minus r. Okay, L r minus 1 over the q. So this is the formula of the discriminant formula of Mourad Sultan Ezouidi. If you want to replace r with 0, then r with 1, then r with 0 and 1, you will get, learners, exactly the following combination: n choose 1, n raised to the power 0 between parentheses minus L0 for the q raised to the power 1 times L minus 1 over the q, plus combination when r equal 1, it will be combination n minus 1, okay, and 1 minus 1 is 0, so that's why here it's written 0. Okay, n raised to the power 1 times between parentheses negative L0 for the q times L0 for the q. Okay, this one raised to the power 0 is 1. So you can see that L0 for the q is a common factor. I will put it here. Then you can note that negative combination n choose 1, in fact, is minus n plus n. So this value, the value of 0 is 0, whatsoever the highest power of your polynomial. Okay, the degree of the polynomial. Now, learners, just practice here. I will practice, or I will calculate the value of S0. We told that S0, learners, I'm looking for my calculator. Okay, calculator, Mr. Mourad. Yes, like that. Calculator. I'm waiting to get my calculator. Okay. Therefore, yes. Okay. Now, learners, we told that L0 for the Q is 60. L1 is 1440. I will just use L0 for the Q. It will be negative 6 times negative 4, because this is negative combination 4 choose 1, negative 4. Okay, negative 4 times 60 plus 4 times 60, so this value is 0, plus 4 times 60. Therefore, learners, hey, you can note that the value of S0 is 0, okay, and the value of this is equal, we use calculator, okay, scientific calculator, okay, no problem, doesn't work this one, okay. Therefore, now I'm going to put, let's say, k equal 2 to find the value of S1. Therefore, learners, you can see here, okay, when k equal 2, I will try to find the value of what? The value of S1. Okay, this is the formula, learners. I will just replace k with 2. I will obtain S2 minus 1, which is S1, equal the sum from 0 to k. K is equal to 2. Therefore, combination n minus r, choose 2 minus r, and raised to the power r between parentheses negative 0 for the q raised to the power 2 minus r multiplied by l r minus 1 over the q. This formula, if you want to replace, you should replace, learners, r equals 0, then r equal, okay, make it in the middle, okay. So when you replace r with 0, we'll get combination and choose 2, L0 for the q squared. When r equal 1, you will get negative n, combination n minus 1, choose 1, times L0 for the q raised to the power 1, okay, because 2 minus 1. And times L0 for the q simply because 1 minus 1 gives you here 0, okay, it will be L0 for the q. And now you can see that L0 squared and L0 times L0 is L0 squared. So this one is common factor. I will put it into parentheses. Combination n choose 2 minus n combination n minus 1 choose 1 times L0 for the q squared plus the square of n times L1 over the q. This value, learners, okay, that is written into inside the parentheses is equal to negative combination 1 choose 1 times combination n choose 2 times L0 for the q plus n squared L1. This one is the generalized formula when k equal 2. Okay, for any polynomial, you should pass through this pathway. Okay, and this has been derived from the discriminant formula of Mourad. Okay, and just replacing k with 2, you will get its own value. Okay, now just calculation, learners. I will use my calculator. I will use 60 and 1440. This is the calculator. Okay, I will just start negative 6, simply because combination 4 choose to 6 times the square of 6. 60 is 3600, means 3600 plus 4 squared is 16. 16, right? Thank you. Plus 1440. This one will give you immediately 1440, means the value of S1 is different to 0 here. Okay, now we continue, learners. Okay, now we want to evaluate the value of S3. I will just set k equals 0 in the discriminant formula of Mourad Sultan. Okay, I will just replace k, learners, with 3 to get 2. Okay, so it will be S3 minus 1 will give you immediately S2. From the sum from 0 to k, learners, is 3. Okay, combination n minus r choose 3 minus r. Okay, because I set k equal 3 times n raised to the power r between parentheses negative 0 for the q raised to the power 3 minus r lr minus 1 over the q. Make sure that the q here can be varied. Okay, can be varied, means can be changed, can be alerted. Okay, and okay, I'll just fix this point here, then I will close the parentheses. Now, learners, I'm going to replace r with 0, then I will get negative combination and choose 3 and 0 for the q to the power 3. Why negative sign? Because negative L0 for the q raised to the power 3 is negative L0 for the q raised to the power 3. That's why here we wrote, or the negative sign had been appeared in front of combination and choose 3. Then plus, learners, n times combination n minus 1 choose 2 L0 for the q squared times L0 for the q. You see this one and that, call it common factor. I will write it here, learners, immediately. L0 for the q raised to the power 3 between parentheses negative combination n choose 3 plus n combination n minus 1 choose 2. This value also can be written as combination 2 choose 1 combination n choose 3 L0 for the q raised to the power 3. The rest values will be written as it is, no change. Okay, so the value of S2, the formula of S2 is that 2 combination n choose 3 and 0 for q raised to the power 3 minus combination n minus 2 choose 1 n squared and 0 for q raised to the power 1 times n1 for the q plus n cubed L2. Okay, now I will just use this formula. Then I should calculate the value of my S2. Okay, means that we are going to use the the discriminant formula of Mourad Sultan Ezouidi. I can see if it is possible. Okay, comes here. So this is we told the discriminant formula of Mourad Sultan Ezouidi that we are going to practice. So this is the value of S2 learners. I will just use the coefficient 61, 1440, and 17280. Okay. I will try to find the value of this. This is the calculator. You can calculate with your teacher, Mourad Sultan Ezouidi, at the same time, and you learn from me new methods. Okay. And these methods will be available for you learners. Okay, because we are here not to hide science, we are here to extend, let's say, your thinking, your fields of thinking. Okay, to evolve your way of thinking and your ways of solving to the power n. Okay, and thanks to God that we reached this level of work. Okay, and has been done after 14 years of work. Okay, sitting on the desk, working on pulling to the power in, and we really solve the pulling to the power 3, power 4, 5, pulling to the power 6, pulling to the power 7, to the power 8, to the power 9. Okay, and up on. Okay, and this simply because we believe that. Everything is possible, and we reach this point. Okay, as we reach the formula itself. Okay, so I will just continue with all that combination 2 choose 1 times combination 4 choose 3 means 8. I will make here 8 times 60 raised to the power 3. Okay, minus learners what? Minus 2 times 16 minus 32. Okay, times 60 times 60 times learners 1440 plus 4 cubed means 64 times learners what? 17,800 280. So this one has to be equal to, okay, I will repeat again. I will repeat my calculation. Okay, we told that this is 2 times 4 is 8. Okay, times 60 raised to the power 3. Okay, good man. Minus, okay, minus 2 times 16 is 32. Times learners 32 times 60 times Mr. Murad. Okay, 1440. Then a plus learns 4 cubed is 64 times exactly 17,280. So this one has to be equal to, yes, 69,120. Sometimes the artificial intelligence will change your output, but we are here more intelligent than this robot. Okay, therefore you can see that 69,120, this is the value of S2. Okay, and we continue learns. Okay, evaluating now the value of S3. Okay, S3. Okay, this one is S3. Okay, this is the formula of your brother Mourad Sultan Ezouidi has to be applied or practiced. Okay, to find the value of S3. Just so I will substitute K with learners with 3. Okay, to solve any polynomial learners, you have to use my own formula. Okay. Okay, this is 4. This is 4 minus r. Okay, and this one also 4 minus r. This is the formula, discriminant formula, when k equal 4. Just I will replace r with 0, with 1, with 2, with 3, and with 4. I will obtain immediately learners the following. S4 minus 1 is S3. the sum from 0 to 4, the sum from 0 to 4. Combination n minus r, choose 4 minus r. Combination n minus r, choose 4 minus r. N raised to the power r. Between parentheses, negative L0 of ODQ raised to the power 4 minus r times LR minus 1 of ODQ. Now, learners, I'll just focus on the first two terms because the rest is going to be easy for you. You can calculate it. You can expand. You can sort it out, okay, by my own formula. Just I'm going to concentrate on the first two terms because I see that L0 for the Q raised to the power 4 here is a common factor. I will put it outside the brackets. Then I will open the brackets to remain only combination n choose 4, okay, minus combination n times combination n minus 1 choose 3, okay, plus combination 2n minus 2, okay, this one, n squared, L0 of ODQ squared, L0 of ODQ squared times L1 of ODQ. Then minus combination n minus 3, okay, combination here, Mr. Mourad, combination, okay, combination, and, yes, here 1, combination n minus 3, I'll close this one, خلاص. Combination minus 1 choose 1 n cubed L0 for the q raised to the power 1 times L2 for the q, okay, plus n raised to the power 4 L2. Then the first two terms, learners, we told there is something common factor. The difference between these two combinations, okay, has to be equal to negative combination 3 choose 1. Why 3 he learns? Because there is a strategy. There is something maybe you can't see, okay, but with practice you can see it, which is this is S3, okay, odd number. So I'll just write combination 3 choose 1, then I'm going to add 1 to 3 gives 4 among n, okay, means n choose 4, okay. So this is a general expression for this first term, plus combination n minus 2, okay, choose 2, then n squared, L0 for Q squared, times L1 minus combination n minus 3, choose 1, and cubed L0 times L2 plus N4 L3. Now I'm going to calculate the value of this. Then I will try to find the value I will use. Let's say 60, 1440, 17280, and 103,680. This is the calculator. I will give you time to think, to calculate with your mathematics teacher, Mourad Sultan Ezouidi, okay, the pioneer in math. Okay, I'll just, we told that is negative 3 times 4 choose 4 is 1, it means negative 3. I'll just write negative 3. Please, Julie, please, go, mom. Please, mom. Yalla, go, please. Please, go. Okay, good, girl. So negative 3 times what, learners? Times 60 raised to the power 4. Okay, raised to the power 4. Plus combination 2 choose 2 is 1 times 60, 4 squared. Plus, I will just write plus 60 because 4 squared. Times 60 squared is 3,600. Times what, learners? 1,440. You can write 40 or 40, whatsoever. Minus combination 1 choose 1 is 1 times 4 cubed is 64. Times 60, learners, times 60 times 17,280 يا جوري. خلاص جوري عاد. Okay. Plus 4 raised to the power 4 is 256 times what, learners? 103,680. So this one has to be equal, learners, to 4,250,880. So you see, 4,250,880. So now I'm going to close this parenthesis, and I will tell that I found the value of sk minus 1 of order r. Therefore, I can write my new polynomial that is, in fact, has a relationship or has kept in touch with the original polynomial. So my polynomial is that, learners, you see, p of x equal x4 minus 60x cubed, okay, plus 1,440 x squared minus 17,280x plus 1,003 103,680 equals 0. Therefore, the new polynomial that I got from my discriminant formula is that, and has to be written as p of x equal x4 raised to the power 4 minus s0 for the q raised, okay, x raised to the power 3 plus s1 of ODQ x squared minus s2 of ODQ x plus s3 of ODQ. Okay, just substitution. This is S1 learners. You can note that S minus 1 is different to 0, S0 is 0, except S1 of ODQ is 14, 1,440, and S2 is 69,180, 20, sorry, S3 is 4 million, 4 million, yes, 4 million, yes, 250, 4 million, 250, I forgot the zero here, yes, 4,240. Okay, now I will write my new polynomial. The roots of this polynomial, you will add to 60. Then you should divide by 4 to get the roots of the first polynomials. Means that if I'm going to explain this, okay, briefly, I will do like that. I need this one. Okay. Therefore, if you want to find the roots, I'll just make like that. The roots I will write here learners alpha, sorry, yes, alpha, indexed, okay, alpha, I will choose any value, okay, this is one, okay. I will make alpha, sorry, no, not this one here, alpha, okay, indexed k belongs to k, belongs to learners to 0, between parentheses 0, okay, 1, okay, 2 now, 3 and 4, okay. This one has to be equal, in fact, should be equal to L0. It comes here. I'll make enter. I'll make enter. Okay. Equal to L0 plus YK from 0, 1, 2 now. Okay. And 4, 2 now we told. Okay. 3 and 4. Okay. 3 and 4. Okay. Divide by 4. Then, this is the general method, general way how can you work with pulling to the power 4. If it is pulling to the power 5, we should divide by 5. If it is 6, divide by 6, and so on. Okay, mean that if I'll just mean that if you have polynomial to the power n, okay, between parentheses I'll just okay, if for example here n, okay, نفترض n minus 1, okay, from 0, okay, n minus 1. Okay, this one learns will give you also the same here, n minus 1. Okay, I'll just write n minus 1, and this is divided by n. Okay, whatsoever your polynomial. As here learns the idea that we are going to solve this polynomial, for example, to the power n, okay, raise it, okay, polynomial to raise it to the power n. Okay, I'm going to extend this one. That's why here I should ignore or exclude one value here. I will make here the 2 comes, okay, the 2 comes. Then I will see when exactly the exponential 2n or 2k plus 1 should be equal to n, okay? Meaning that I will just exclude or excluding what learners we told 2k plus 1, 2k plus 1. I will use this, okay, I will use this answer, but I will use this, okay, sorry. I will use this. You have to exclude root simply because you are going to use to extend the power. Okay, therefore, I will just write this as, okay, I will erase all of this. Okay, I will write here 2k plus 1 equal, okay, equal n minus n minus 1 divided by 2. Okay, minus n minus 1 divided by 2 here. N minus 1, n minus 1, n minus 1 divided by 2. this is that you should exclude it, okay, from this one, okay. I'll just write, I will write, okay, different, no problem here. We should do like that, okay. Erase this, exclude, okay. I will exclude this. Means the k has to be different, okay, has to be different to this value because you will get the value 0 when you extend your polynomial. I'll try to find the different sign. Or is it? I thought somewhere. Yes, this one. Here, k has to be different to n minus 1 divided by 2. That's why if the power is 5, so n minus 1, n 5, 5 minus 1, 4 divided by 2. That's why he excluded the 2 here. Okay, but we continue learning. Now I'm going to find the value, the roots of this. After finding the roots of this, is called yk from 0 to n minus 1. Okay, divided by n. The n is 4, therefore I should exclude all the other roots except y0, y1, y3, and y4. Now I'll just give you the solution. So there is a relationship here between learners, between polynomial to the power 5 and polynomial to the power 4. I'll just go back to the, at the end, I will make alpha, the roots of my polynomial is that is 60 plus 60 exponential to k plus 1 I pi over 5, all divided by 5. You can see that 60 divided by 5 is 12. 60 divided by 5 is 12. So the answer is 12 plus 12 exponential to k plus 1 I pi over 5. You can see that, meaning that your polynomial, your original polynomial to the power 4 has to be extended to the new polynomial to the power 5. Yeah, Juri, barhom, barhom. Okay, so now I should extend now my polynomial. My first polynomial learners is p of x equal x to the power 4. I will extend this. Minus 60x4 plus 1440x3 minus 17,280x squared plus 103,680x. Simply because I extend my original polynomial to the power 4 by x, or I multiply this by x to get a new polynomial to the power 5. Then I has to do the same process that we did for finding the for finding the value of SR, because it's very important. You can solve any problem without using the discriminant formula of Mourad Sultan Ezouidi. Okay, close your eyes, close ears, sorry, but your mind has to be smart. You should use the discriminant formula. Okay, so just check if YouTube is works. Sometimes yes, it works. Okay, now learners, it's better now to concentrate, okay, to get the point, okay. And you can also give this example to your friends to do it again. It's very very important examples, okay, that Mr. Mourad Sultan Ezouidi had written and published their his own books, okay. I'll just show you where exactly question, okay, but give me just okay, I will come here. Okay, Facebook, Mr. Murad. Okay, wait for me, learners, so that you can make coffee or drink your espresso and don't go so far from live session. Okay, I'll just come here, learners. Okay, Mourad Sultan Ezouidi. This is also another book in Amazon. Okay, these books have been published for your sake, learners. Okay, I'll just come here. Okay, okay, okay. Yes, I am now live, learners. Okay, so I'll just focus on one example for you. The example that okay, okay, www.mybestseller.couk. Okay, so in fact, I do thank UK country for publishing my books. Okay, and they sent for me my paperback. Okay, means that I got my own paperback, and this work has to be appeared. Okay, or has to be spread out as fast as we can. Okay, if we learners want to know about the new methods of Mourad Sultan Ezouidi, that really it's very hard to reach this level of intelligence. Okay, that really solve the problem to the power n. Okay, some other methods that we learned before as students or as teachers or as professors, we used the approximation method and the method of Newton. Okay, xn equal xn minus 1 plus fraction f of x and divide by f dash xn. Okay, these in fact are bad methods. Okay, they will never give you the exact value of the polynomial. Means a polynomial with highest power n has n roots. Don't tell me that I approximated. Hey, after approximating, what is the roots? What are the roots? So we want, let's say, fix or absolute value, like absolute value of a root. Okay, means we want a single root that contains all the roots or contains, let's say, the exact value, the roots of this polynomial to the power n. Okay, and me as Mourad Sultan Ezouidi, your youngest brother, I did this. Okay, so let's focus on this, learners. Here an example of my books. Okay, that had been published. Okay, you see this one, polynomial to the power 6. Okay, so we use the discriminant formula of Mourad Sultan Ezouidi to find the exact roots. There is no approximation method. There is no error estimation while using this method, these techniques, these strategies. Sorry. Okay. So this book's learners consist of many polynomials raised to the power 6 solved by Mourad Sultan Ezouidi. You can use the discriminant formula to find all the zero. Okay, meaning that it's not likelihood, okay, or is not the probability that you are going to find a root by approximation or by Newton method. No, there is a rule, okay, there is a formula, there is a way that you should follow. Okay, let's say if we want to approach the idea, there is a new ideas, okay, that helps your mathematics teacher Mourad Sultan Ezouidi to reach this level. Okay, so and the book here is not too expensive. Any student, any professor, any teacher can let's say buy it, or if you are studying in governmental schools, the school itself can bear and buy this for you as a gift. Okay, so let's continue learning. I will just close this parenthesis. Okay, and we'll continue. This is my best friend Dr. Ahmed Mashani. Okay, and this is my best friend Maher Zaidi. Okay, this is my brother Jad Sultan Ezouidi. Okay, and this is my uncle Eid. Okay, so let's continue learners. Okay, this is also my friend Zahri Hadi. Okay, we were in Mecca together. Okay, and we did Umrah. So we continue learning. I told that here we should do what exactly? We should solve polynomial to the power 5. You see, in a question, in this question, don't just work on with polynomial to the power 4. You should be very smart and try to work also with polynomial to the power 5 after extending the power and see your results. Okay, now learners, it's clear that is polynomial to the power 5. Okay, that we obtained after what learns after extending the power of polynomial to the power 4. So in order to find out the roots of this polynomial, we should determine the value of SR learns relative to LR of ODQ. Here R, of course, belongs to -1, 0, 1, 2, and 3. Let's focus on these learners. We have now we have a formula, discriminant formula. This discriminant formula is called the discriminant formula of Mourad Sultan Ezouidi. You will try to use and try to let this formula be familiar with your hands, with your pens, on your notebooks, and your laptops, okay? Because it's very important. You can't go through without using this discriminant formula, okay? So therefore, learners, I'll just use this if it is possible, learners. Okay, after your permission, of course. Okay. Now, learners, I'm going to set, okay, set, let's say k equals 0. We write s minus 1 of order r is 1. This is by convention, okay, because the sum from 0 to 0 here of this value is 1, okay. Now, I'm going to find s1, learners, is the same as here s0, learners. Just I will use here the discriminant, okay, the discriminant formula of Mourad Sultan Ezouidi, so that, okay, so that we can, yes, so that, learners, we can find the value of S0. You can see this one, learners. I'll just replace k with 0. We'll obtain what exactly? 1 minus 1 is S0 of order R. Then sum from 0 to k is equal to 1. Okay, sum from 0 to 1. Combination n minus r, choose 1 minus r, learners, and raised to the power r minus L0 of order q. 1 minus r comes simply because k is 1. Okay, a times L0 of order q of order times LR of LR minus 1 of order q. Now, learners, this is the discriminant formula of Mourad Sultan Ezouidi, means that you can't, let's say, go through working the value of s k minus 1 without this formula. Now, learners, we'll just go so fast. So the value of S0, learners, after replacing R with 0 and R with 1, we will note that there is something common factor which is called L0 for the Q. Then you will put it outside the brackets like that. Then n, this is n, minus combination n choose 1 is n. So the value of S0 for any polynomial to the power n is 0. Therefore, if you want to practice it using your own calculator, you just do this as your teacher Mourad Sultan is doing now. Okay, I'll just replace combination 5 choose 1 is -5, okay, because there is -5, times 60, okay, plus 5 multiplied by 60, okay. So this one, learners, is equal to 0. Therefore, the value of S0 is 0 for any polynomial to the power n. This is known by you now, okay. Now, learners, I'm looking for finding what exactly? Finding the value of S1, okay. Here, to find the value of S1, learners, you should put, okay, k equals 0, okay. I'll just put this here at the end. Now, okay, this is, I want to erase this, Mr. Mourad. Okay. Okay, so this one, learners, is called the discriminant formula of your teacher, Mourad Sultan Ezouidi. And you are lucky simply because you get new methods to work with polynomial and to know each part in the polynomial by the method of your teacher, Mourad Sultan Ezouidi. So therefore, I just use this one. Therefore, this is the formula of Mourad Sultan Ezouidi. I'll just make like, okay. Now, learners, I will continue. We told that if you want to find the value of S1, just go to the formula and replace k with 2 because I want to obtain 1. This is 2 learners. Of course, this is 2. Okay. I wish that you got the point. How can you find the value of sk minus 1? Yes, for the q. Okay, so after replacing learners, this is the same formula as that. Okay, after replacing r with 0, with 1, with 2, and please قيم with 2, you will get the combination n choose 2, L0 of order q squared minus n combination n minus 1 choose 1, L0 of order this one squared. That's why here common factor, I will put it here, L0 of order q squared between parentheses. The difference between these two things, learners, okay, is the difference between combination n choose 2 minus n combination n minus 1 choose 1 is minus 1 choose 1 combination n choose 2. Okay, so times L0 for the cube plus n squared L1 for the cube. This one, maybe you know about quadratic formula, but this is the opposite of the value of quadratic formula. Okay, meaning this formula, it's very, very generalized. Okay, when you are, if you want to think of quadratic formula, just change n with 2. It will be 2 squared is 4 times L1, which is times L1, which is C, okay? L0 for the Q, in fact, is L1 is C divided by A, and L0 for the Q is B divided by A, all squared. So this one is the opposite of the quadratic value that you already know, okay? Now, after calculation, learns, just you will calculate the value of this. I will obtain this one. You can use this one and use your calculator. You will see that is the value of S1. Please, S1 is 0. I will just write negative 10 because combination 5 choose 2 is 10 times 60 squared means 3,600 plus 25 5 squared plus 25 times 1,440. This one, learners, is equal to 0. Therefore, S1 equals 0. Okay, S1 equals 0, Mr. Muhammad. Now, I'm going to find S2, learners. To find S2, you should, learners, okay, to find S2, yes, to find S2, learners, okay, comes here, Mr. Murad. Okay, to find S2, learners, you should set what? You should set K equal a 3. Means what? I'll just interfere to explain this for you. Okay, just give me time, learners. Okay, okay, Mr. Murad, this one is better. This one we told is the the formula of your mathematics teacher, Mourad Sultan Ezouidi. It's called a discriminant formula for of Mourad Sultan Ezouidi that helps you to find the value of sk minus 1. Therefore, we told I want to find here, we told that we should set k equal 3, just replace k with 3. We will obtain 3 minus 2, 3 minus 1. Okay, from 0 to k is 3. Then combination n minus r to 3 minus r, then 3 minus r. Okay, now just I will close this discriminant formula. Then I'm going to distribute or replace r with 0, r with 1, r with 2, r with 3. I will obtain immediately, learners, I explained this before. I will go to this one. S2 of r, learners, is 2 combination and choose 3. Why 2 combination? Because negative combination n choose 3 plus n combination n minus 1 choose 2 is 2 times combination n choose 3. Okay, I can simplify more. It will be combination 1 choose 2, then this is 3 and choose 3. Okay, plus minus combination n minus 1 choose choose 1 n squared 0 for the cube times L1 plus n cubed L2. I'll just use the last formula, this one. This S2 had been developed from the discriminant formula of Mourad Sultan Ezouidi when k equal 3. Okay, now we'll just go to continue. This is the formula learns. I will try to guess the value of S2. At the same time that your mathematics teacher is going, your researcher, Tunisian mathematics teacher is going to calculate this for you. You should also do the same as, okay, like that. I'll appear my calculator now. So Here, learners, I will just explain everything for you. Okay, okay. So it will comes from here. 2 times 10, because combination 5 to 3 is 10, 20. I'll just write 20 times 60 cubed times 60 raised to the power 3. Okay. أرهوم يا يقين يقين يقين. Come on, eh? بسرعة. Okay. Minus 3, learners, times 25 times 60 times 60 times 1440 plus 125, because 5 cubed, times 17,280. This one, learners, has to be equal to 0. Therefore, this one comes here. I will see, yes, the value of this is 0. I'll check something happened. Okay, my stream, where is my stream? I'll check the stream first, learners. Okay, yes, okay, it works. As we told that, I'll just we found the value of s2, which is 0. Therefore, we can, let's say, recognize our new point to the power 5. Okay, mean that s0 is 0, s1 is 0, s2 is 0. We'll focus on s4 has to be equal to 0. Then the value of, sorry, the value of s3 is 0, and the value of s4 it will be different to 0. Therefore, I will go to continue solving the equation. I'm going to now set k. Sorry, again, Mr. Mourad. Again, Mr. Mourad, please, if it's possible. Yes, good man. I will come here. Okay. Now I'm going to set k equal what, learners? Equal 4. Equal 4 to get what? To get the value of s3. Means here in my formula, I'll just replace k with 4, learners. 4. This is 4, of course. So at least now you had been to be familiarized. Okay, you are familiar. Okay, okay, I have to say it. I forget, no problem, but I'm going to correct the mistake. Okay, so I will just write 4 here as it is till the word comes. Okay, sorry. Okay, now this is the value of S3. Okay, I will use just the formula of your pioneering methods, Mourad Sultan Ezouidi. Okay, and I will just show this is the formula, learners, of me, of course. Okay, okay. So just I will use the discriminant formula of Mourad Sultan Ezouidi. Okay, where k equals 4. 4 minus 1 is S3 of order R. Sum from 0 to 4. Sum from 0 to 4. Combination n minus r. Choose 4 minus r. N raised to the power r. Then minus L0 of order q raised to the power 4 minus r times LR minus 1 of order q. Now, when replacing, learners, n r with 0, you will get combination and choose 4. L0 of order q, choose to the power 4. When r equal 1, it will be minus n combination n minus 1, choose 3. L0 of ODQ to the power 4, because this one can be the product of two value, which is 4, plus combination n minus 2, choose 2. N squared, L0, Q squared, L1, minus combination n minus 1, choose 1, n cubed, L0 for the Q raised to the power 1 times L2 plus N4, n raised to the power 4 times L0 for the 3, L3 for the Q. Now, after simplifying, learners, you see this one? I mean this, this, L0 for the Q raised to the power 4, and here also L0 for the Q raised to the power 4. These two terms have common factor. I put this as a common factor. Multiply by what, learners? By combination, n choose 4 minus n minus 1 choose 3. This value, learners, you see this one is in fact to negative combination, 3 choose 1, or you just write 3 times combination n choose 4 times L0 of order q raised to the power 4. Therefore, learners, this one, the rest terms when r equal 2 and 3 and 4, it will be the same. You just develop the formula, discriminant formula of Mourad Sultan Ezouidi, and write it down here. Now, just after finishing developing the value of S3 in terms of combinations and the coefficient, we just calculate the value of S3. Here, learners, this is the calculator. I'll just erase everything. I will start from 3 times 5 is negative 15 because there is negative 5, negative, times 60 raised to the power 6, times 60 raised to the power 4, good man, plus learns what, plus 3 times 25 means 70 plus 3, okay, times 25 squared, 25 only, times 60 squared, which is 3600, times 1440 minus 2 times 125, it will be 250, times 60 learners, times 17,280, plus 5 raised to the power 4 is 625, times 103, 680. So this one has to be equal, learners, 0. You see, the value of S3 is 0. Okay. Now I will close this one. I'll go down. In order now, learners, to find the value of S4, okay, I want to find the value of S4, I should use, I will write, use the discriminant formula of HSM. HSM means Mourad Sultan Ezouidi. HSM. H is the name of my mom, S the name of my father Sultan, and M is Mourad. Okay. Now, learners, I'll just use this one if it is possible. Okay. Now, I will use this formula, learners. Means that I should set k equal 5. Okay. I will go to the discriminant formula. I will replace k with 5. With 5? Yes, with 5, Mr. Mourad. K with 5. The formula never change. Okay. 5. Of course, 5. Now, learners, just developing this formula will obtain S4 equal negative combination n choose 5 L0 raised to the power 5 plus n combination n minus 1 choose 4 L0 for the q to the power 5, because this multiplied by this gives a power, gives L0 for the q to the power 5 minus combination n minus 2 choose 3 n squared L0 for the q cubic L1 plus combination n minus 3 choose 2 n cubed L0 for the q squared L2 minus combination n minus 5 choose 1 n raised to the power 4 times L0 for the q times L3 plus n5 L4 of ODQ. Now, learners, you can see these two terms. The rest has to be written as they are, not change. But I'm going to simplify the first two terms only when r equals 0 and when r equals 1, because there is something in common. I will just write negative combination n choose 5 plus n combination n minus 1 choose 4. This one has to be equal, learners, immediately equal to combination 4 choose 1 or just 4 as you like, times combination n choose 5 L0 for the q raised to the power 5 minus combination n minus 2 choose 3 n squared L0 for the q cubed times L1 plus combination n minus 3 choose 2 n cubed L0 for the q squared times L2 for the q minus combination n minus 4 choose 1 times n4 n raised to the power 4 times L0 for the q raised to the power 1 times L3 of ODQ plus n raised to the power 5 times L4 of ODQ. Now, I'll just use learners the calculation, my own calculation. I developed the value, the expression of S4, okay, that has been derived from the discriminant formula of Mourad Sultan Ezouidi. Now, I'll just calculate the value of this. Okay, let's focus on the value. This is my calculator, learners. I will set at 0. Now 4 times combination 5 choose 5 is 1, means 4 times 60 to the power 5. Okay, 4 times 60, not 0 times 4, sorry. This is 0 times 4. Okay, we told 4, okay, times 60 raised to the power 5. Okay, minus learners minus 25, 5 squared, times 60 raised to the power 3, okay, times what? Times 1440 plus 125 times 60 squared, which is 3600, times learners 17,280, minus 5 raised to the power 4 is 625, times 60 times 103,680, plus 5 raised to the power 5 times 0, so it's 0. I'll just make calculation, equal sign. This one has to be equal to negative 777,600,000. Okay, so this one, learners, if you can see, in fact, is equal to this one. You can divide by between parentheses negative 60 raised to the power 5. 60, what is it? Sorry. Okay, okay. How can I do it? Okay. I will come here. I will come to my ancient. Yeah, this one. I will take this one as I will copy this. This is the value that we already calculated. Now I come here, learners. Okay. I will make divided by between parentheses negative 60, close the parentheses, raised to the power 5. So this one has to be equal, in fact, to 1. Okay? Means that this one, I can write it here, in fact, equal between parentheses. Okay, I will make a symbol first. Okay, this is 5. I will come there. Negative 60 raised to the power 5. Okay, means equal, in fact, to, if you want, okay, خلاص, I close the parentheses. Now I continuing learners. Now I got the value of uh, S0, S1, S2, S3, and S4. Except S4 is different to 0. Therefore, my new polynomial to the power 5, this one that I had that had been extended to a power 5, extended to a polynomial to a polynomial to the power 5. So x p of x equal x to the power 5 minus 60x4 plus, this is of course 100 and 1,440 minus 17,280 plus 103,680x plus 0. I'll just write here plus 0 because I extended the original polynomial to the power 4 to a new polynomial to the power 5 to see the relationship between these two polynomials. Okay, therefore I should solve this polynomial to the power 5 here. Okay, now I can wrote this as that. We can see that after exact work that S0, S1, S2, S3 are equal to 0. Expect S4 of order Q is negative 777,600,000. Okay, now I'm going to write my polynomial. This one I should simplify this. I will just keep the first term with the highest power 5 and the last term with the highest power 0, highest power 0. Okay, means x to the power 0. That's why it's written S for k. Then uh, q, sorry, then p of x equal x to the power 5 minus s4 of order q equals 0. Means, learners, I will transfer this on the right hand side, gives x raised to the power 5 equal s4 of order q, which is equal, in fact, negative 777,600,000, which is equal to negative 60 raised to the power 5 times 1. Okay, now x5, learners, is equal to S4 of order Q exponential 2i k pi, simply because 1 can be written as exponential 2i k pi. Therefore, xk from 0 to 4, we have 5 roots of this polynomial. Okay, that will help you to solve this one, the previous one. And after finding the roots of this one has to find the roots of the given polynomial from the beginning. Now I'll just write xk from 0 to 1 to 4 is the fifth root of s4q exponential to I k pi equal also uh, okay, equal, okay, I will just write now exponential 2 ki pi as a fraction divided by 1 because I should divide also by 5. So the last answer has be equal to fifth root of s4 of the q exponential 2 ki pi over 5. Now just replace s4 with its value. So this is the xk, the roots of this, okay. Therefore, it will be equal to the fifth root of negative 60 raised to the power 5 times 1 exponential 2k I pi over 5. But you can see minus 1. I can write exponential I k pi. Okay, minus 1, I will just write exponential I pi. Okay, therefore, 60 raised to the power 5, all raised to the power 1 divided by 5 is 60. That's why here 60 is outside. Then exponential I pi, the fifth root of exponential I pi learns has to be equal to exponential I pi over 5 times 2k exponential 2k I pi over 5. We have two bases e exponential, but different bases, different indices, and same base. So I should multiply both of them. So the last answer has to be equal 60 exponential 2k plus 1 and pi over 5. Therefore, beta is the roots of this polynomial, and also it's a part of the roots of the original polynomial, which is x4 minus 60x3 plus 1440x2 minus 17 to 80x plus 103,680. Therefore, now just use the formula. This is with the highest power 5, I should written beta. K belongs from 0 to 4, L0 for dq plus xk is xk divided by 5 because the highest power is 5. So after calculation, it will be 12 plus 12 exponential 2k plus 1 I pi over 5. Look, learners, when when k equal to, if k equal to here, it will be 2 times 2, 4 plus 1 is 5, divided by 5 is 1, times I pi, means exponential I pi is minus 1 multiplied by 12 minus 12 plus 12 equals 0, means this is the first root of this polynomial. It's clear it is 0. The rest roots, it's at the same time roots of this polynomial to the power 5 and roots of polynomial to the power 4. That's why here, learners, if you are going to go back to the polynomial to the power 4 that we started with, we told that the roots has to be equal or has to be written as the following, okay, as that 12 plus 12 exponential 2k plus 1 I pi over 5. That's why here we exclude the value 2, k equal to, okay, because when k equal 2, we'll get 0, and 0 has to be the root, it has to be one root when you extend this point to the power to the power 4. Thank you for listening, learners. I'll just okay, save this. Okay, I'll see if it is okay. Yes, successfully. Thank you for listening. This is your mathematics teacher, Mourad Sultan Ezouidi. Okay, always will handle with this subject. Okay, and I wish that is clear for you, learners. Okay, thank you for listening and goodbye. Okay, just go back to this again.